Some of the capabilities is a very flexible clock design structure. So the clock structure here is set up using this button here. On either you can select it here on the GUI itself, or there's a gear icon up here, and then in that corner you can then select it from there as well. Selecting the clock here. Now on the silicon, there's two silicon clock oscillators on the chip that are available. These can be set to independent frequencies. They can run anywhere from half a megahertz to 32 megahertz. If you'd like, you can also bring in a clock from the external world via four GPIOs, two for the first clock and two for the second clock. In this case, for this example, by default, the clock that's starting on, we have a 4 megahertz clock being split into 7 equal phases. That gives you 571 kilohertz switching frequency, and each of these are phase spread. Similarly, on the second clock, we have a 2 megahertz clock that's being binarily divided down, and that's being split down from 1 megahertz down to 8 kilohertz. The colors correspond to which clock you're adjusting. Out of these 16 clocks, you can choose 8 clocks that you want to output. So you can either select clock A or clock B. So here, if I select this to clock B, this will change colors, and clock B will now be output on this clock output. Each of these clock outputs can also then be named to be used later in the tool. So I can call this my buck 1 clock, or whatever we wanted to call it. Once you click OK, these will then be used later in the tool for different power regulators that you might drag and drop into that.